Hi, I'm Cheryl Leach. In this problem, we're going to be using the areas of rectangles to approximate the area under a curve. And after we're finished, we're going to check our result by doing a definite integral and calculating the exact area. All right, well, let's see what I mean about using rectangles to approximate that area. We want to find the area under my curve minus x plus 3, which is just a line, from 1 until 3. Instead of using a definite integral, though, I'm going to construct some rectangles and calculate the area of each of these individual rectangles, add them up, and come up with my approximation. You can see that each rectangle will lose a little bit of the area under my curve, but then gain a little bit more. Here we've lost a little, here we've gained a little. That's why we have an approximation. All right, so to get the area of a rectangle, we have a geometry formula. We know it's going to be the width of this rectangle times its height. Well, let's take a look at the width first of all. The width, I'm going to use a delta x as its representation. And the entire interval is going from 1 to 3. So I'll take b minus a, or the length of the entire interval, and divide it by how many rectangles I'm going to use. In this particular case, I'm going to be using 4 rectangles. So I'm going to divide by n, which is the number of rectangles. So in this problem, I have 3 minus 1 all over 4. So each one will have a width of 1/2 unit. All right, so now I know the width of each of these rectangles. Now I'd like to calculate the height of them. Well, how do I calculate the height? It looks like I'm taking the midpoint and I'm using the value at the midpoint of that interval to calculate my height. That's exactly what I'm going to be doing in this particular problem. So let's take a look at my first interval that I'm using. Now, I know I'm starting at 1, and I know that the width is 1/2. So my first interval will be the interval from 1 to 3/2. Well, what's the midpoint of that interval? The midpoint of that interval, think of it as find the midpoint of these 2 points. Now, the y-coordinate of those 2 points will be 0 in both cases. So I'm really interested in what's the x-coordinate of the midpoint. And to find that, we're going to add our 2 x-coordinates together and divide by 2. So 1 plus 3/2 is 5/2, divided by 2 will be 5/4. Now we'll look at the next rectangle. Again, I'm interested in calculating the height at the midpoint. This interval goes from 3/2 to 2. Using the same technique we did before, we're going to add these 2 numbers together. So we're going to have 7/2 divided by 2, and we'll end up with 7/4. Repeat the process for my third rectangle. To find the midpoint, I'll look at the interval starting at 2 and ending at 5/2. We'll add these 2 together. That's 9/2 and divide by 2. I get 9/4. One more time, find the midpoint of my last rectangle. The interval I'm looking at is 5/2 to 3. So I'll have 11/2 divided by 2 and 11/4. All right, now that we have all of the midpoints, we have to consider the height of those rectangles. Now, the rectangles do not have heights of these midpoints. The heights are actually the function values at those midpoints. So I want to calculate what f of 5/4 is and what f of 7/4 is. So let's add another column for the height of my rectangle. And for my first rectangle, the height is going to be f of 5/4, which, according to my function, will be minus 5/4 plus 3, or in other words, 7/4. Doing the same thing with my next rectangle, the height will be the function value when my input is 7/4. So f of 7/4 is going to be minus 7/4 plus 3, which is 5/4. For my third rectangle, the height will be the function value when the input is 9/4. So I have f of 9/4 equals minus 9/4 plus 3, or 3/4. And finally, for the last rectangle, I'll have f of 11/4 as the height, which will be minus 11/4 plus 3, or 1/4. Okay, we're ready to calculate the area now. Now, how do I find the area? Well, I'm going to take the sum of the area of the rectangles. So I'll have the area of the first rectangle plus the area of the second plus the area of the third and the area of the fourth rectangle. Now remember, an area of a rectangle is the width times its height. So for my first rectangle, the width is 1/2. And the height is f of 5/4. In my second rectangle, the width is still 1/2. And the height this time is going to be f of 7/4. For my third rectangle, 1/2 for the width and f of 9/4 for my height. And finally, the last rectangle has a width of 1/2 and a height of f of 11/4. Okay, now I notice that there's a 1/2 in each of those terms, so I can factor that out. So I'm going to have 1/2 times the quantity f of 5/4 plus f of 7/4 plus f of 9/4 plus f of 11/4. And I've done a lot of that calculation already. I know that f of 5/4 is 7/4. F of 7/4 is 5/4. F of 9/4 is 3/4. And f of 11/4 is 1/4. If you add all these together, I've got 12, 13, 14, 15, 16/4. So that's 1/2 times 16/4, which is just 4. And so my total area for the approximation is 2. Now that's the area of the 4 rectangles added together. Let's see how accurate I was. I can also calculate the exact area by doing the integral. And I'm going to be integrating from 1 to 3. And my top function is minus x plus 3. The bottom function is 0, so I'm not subtracting anything. And I simply have the integral minus x plus 3 dx. Integrating, I have minus x squared divided by 2 plus 3x, evaluated from 1 to 3. Plugging in my upper limit, I'll have a minus 9/2 plus 9. And then I have to subtract what happens when I plug in my lower limit. When I plug in my lower limit, I'll have a minus 1/2 plus 3. All right, so for a total, I have a minus 9/2 plus 9 plus 1/2 minus 3. And that gives me a total of 2. Notice that in this case, my approximation really did equal the exact area under the curve. Now be careful with this method though. This only happened because I had a triangular shape. Okay. For many curves, this will be an approximation and the definite integral will give you the exact answer. I hope this helps. Thanks.